So, for the 6-2 lesson, I will go back and record a 6-1 lesson. We are looking at reviewing from pre-calc, right? So, pre-calc, we had this y equals y naught e to the kt formula for any exponential growth or decay formula, right? This is actually the calculus of it, proving we separate the variables, we take the integral of both sides. We actually show that e to the c is the initial value. And so now it works for every problem. And this example too essentially is, with the exception of assuming that the rate of increase is directly proportional to the population, that tells us this is an exponential growth problem, right? And so we go to our go-to formula. We plug 400 is the initial amount. 1600 was the amount after time 3. And we solved for our k. Remember, got to take the natural log of both sides. So our k is natural log of 4 over 3. So here's our appropriate equation. Y equals 400 e to the k, which is natural log of 4 over 3, t. There's our answer. Find the number of bacteria at the end of 6 hours. What's that going to be? Y of 6. So that would be 400 e to the ln of 4 over 3 times 6. It is a calculator permitted problem, because if it was not, it would not be fun. 400 e to the natural log of 4 divided by 3 times 6 would be 6,400. Bacteria, right? Now, the only difference between example 3 and example 2 is when will the mass be reduced to something. So, I guess we can go ahead and do this one. Again, half-life, we know it's directly proportional to the amount. So y equals what? Y naught e to the kt. Loses mass, half-life. What does that mean? The amount of time it takes for what? Yeah, to be halfway gone away. If we're starting out with 100, that means we would end with 50. E to the k times 1590. Now, I'll tell you, if I'm figuring it out, a lot of times I don't even write 150. I just go ahead and write a half, because 50 divided by 100 will always be a half, right? And so then to find the t, or the k, sorry, to find the k, what do we do? Natural log both sides, power down in front, and the natural log of e is just 1. So our k is natural log of 1/2 over 1590. And so the formula would be y equals 100 e to the natural log of 1/2 over 1590 t. Find the mass after 100 years. That's just y of 100, isn't it? Plug and chug. 100 e to the ln 0.5 divided by 1590 times 100. Yeah, times 100. Up there. 95.734. And it is in milligrams, right? Does it make sense? It's only lost a little bit of its mass after 100 years?
Yeah.
Why?
Because it lives for like 3,000.
Oh, it lives for a lot longer than that. If the half-life is 3,000 something, so a quarter of it would still be there. A quarter of it would still be there after 3,000 years, right? Because half of a half is a fourth, right? All right, so when will the mass be reduced to 30 milligrams? Well, 30 equals 100 e to the ln of 1/2 over 1590 times t. And so here we're just solving for the t, right? What are we going to do first? Divide by 100. That's 3/10, right? What do we do to solve for that t? Aluminum. Power down in front. Natural log of e is 1. So what are we going to do now to actually solve for the t? Flip and multiply. Flip and multiply them. Flip and multiply. $15.90 times ln 3/10 divided by ln of 1/2. I think I put it in right. $2,761.775 years. All right. Question? No, I flipped it. I multiplied it by the reciprocal of k. Yeah, because the k was being multiplied by t, so I could have divided by k. Yeah, I could have divided the ln of 3/10 by k. All right, let's see if we even have to do this problem. Ooh, what about, there's a couple. Ooh, the rate of change of w, write and solve a differential equation. The rate of change of w, dw dt, not b, dw dt is proportional to x. Oh, with respect to x, sorry. dw dx is k times x plus 18. Ooh. So now there's no w in there, is there? So multiply by dx. And we just have our w already. K stands for a constant, right? Keep it out there. What's the integral of plain old x? X squared over 2. Integral of 18. Now, honestly, that was kind of a jump because we can do that in the 6-3 section. But I do want you to understand that whole directly proportional thing. Just give me the, don't solve it, just write it. The rate of change of y with respect to time, or respect to t, is directly proportional to 5y. What would I write there? Equals the directly proportional means we have that constant of proportionality, right? Yeah. And then we would do the same thing we did in our proof before. But I'm just, you know. This one is already given. So let's go ahead and divide by the t minus 70, multiply by the dt. What about that little integral? Is that u prime over u already? ln absolute value of u, kt plus c, em again, just like we did in the proof, right? And that's going to be, you know, I guess we can't really call it why not. Let's call this C1 and say C e to the kt, 70 plus C e to the kt. A cup of coffee is placed into a 70-degree room. The temperature is 140 initially. Okay. So if initially it's 140 at time 0, what's the C going to be then? 70 plus C times 1 equals 140. What's our C going to be? $70. So our formula would be 70 plus 70 e to the kt. Oh, 1 hour later, it's 102. So now we can actually find our what? Our k, right? The rate. So 102 equals 70 plus 70 e to the k times 1. Subtract our 70, is that 32? Is this ringing a bell from the problems you ended the year with last year, I hope? Oh. Y'all did it at the beginning of the year. Yeah, y'all, it would have been like a year and a half ago for y'all. 32 over 70. I'm just reducing my fraction. 16 over 35. ln both sides. What does our k equal? ln of 60 over 35. So our formula T, and we want to know what is the temperature of the coffee after 3 hours? T of 3. 70 plus 70 e to the ln 16 over 35 times what? 3? It's only 76.687 degrees. Alrighty, so what you have is only 4 of those. Now, I will tell you, don't worry about these charts. This was another teacher's rendition. He always made them use their charts. I kind of like the way that he shows the grid lines so you can see, you know, exactly where 0 is and 45. But on the AP exam, they're more like these, where you just are given the dots. So there's only 4 there, and then a few of those word problems. So see how many you can get done. I will say it's not going to be terrible.